Right, okay, let's look at another examples here. So, okay, you can pause the video and try to look at the examples, or you can use my lecture notes. So, a diagnostic test is used to detect a certain disease which is known to afflict 3% of the population. Alright, so means that a certain disease which is known to afflict 3% of the population means that among the population, 3% is have the disease. When applied to a person with the disease, right? If the person have a disease, it give a positive response with 95%, right? 0.95. When applied to a person who does not have the disease, it's give a positive response with 0.01%. And is 1%, right? So 0.01. The test is applied to randomly chosen member of a population, right? So okay, let's look at this problem here. This problem is actually relate to tree diagram. Okay, we need help of tree diagram to helping us. A diagnostic test is a diagnostic test. They want to test the reliability of the diagnostic test. Boleh percayaan. So a diagnostic test is used to detect a certain disease, right? Just like COVID-19, right? COVID-19 test. So the test, is it effective or not, right? Now they want to study that. So the diagnostic test is certain disease. So then they know that among a population, 3%, right? 3% is 0.03, right? 3%. So we'll have that disease, right? We'll have that disease. And 97%, right? 97% is 0.97. Total up, these two will be 1, right? You are getting 1. So it's either the population, among the population, either they have disease of the disease or don't have that disease, right? So with the disease is 0.03. All right, and the question continue by stating that when applied to a person with disease, right, is give positive response with 0.95. Means that it's positive response. You give a positive response with 0.95, right? Means the test is quite good, right? It's quite good, but not perfect, right? Not perfect yet. It's 95%. If positive, means that if the person got disease, 95% it will show positive is 95%, right? So, but unluckily, malangnya, it still can show negative even though you have the disease. Means that the test is still need to be improved, right? It's 0.05, right? Even though it's lower, right? 5% from those who have the disease, already have the disease, but go and test, get negative result. Then he maybe that person when going out infect other person, right? So means that we need to improve the test, right? So this is the way the use of probability here. So this is also positive and negative. No disease. Then again, you see that when applied to a person who does not have the disease, is give a positive response with 0.01. 0.1% is still, this is called malang, right? Unlucky, very unlucky. Because why? So no disease but test to be positive and you need to be quarantined, right? This is very dangerous, right? So means that, but we have no choice, right? That's the test we have, maybe, all right? So then, of course, this will be 0.99, 99%. This is unlucky, right? 99% you will test negative if you don't have the disease, right? It's still considered okay, right? So calculate the probability that okay, look at the question. Calculate the probability, right? Calculate the probability that a positive response is obtained, right? A positive response is obtained means that the probability of positive response. The positive response can come from the person have the disease, right? Or the positive response come from the person who do not have the disease. So means it's either you have the disease and you give positive response, or you don't have the disease but you still getting a positive response, right? So very easy. I just taking 0.03 multiply 0.95, right? 0.03 multiply 0.95 plus weight, do not have the disease but test positive, 0.97 multiply with 0.01, right? Some students were asking, sir, why do you multiply? Why you multiply? Because why? You see, you have positive. This is positive given that person have the disease, right? Have the disease. You know that person have a disease, but you test and get positive, right? If you multiply with probability of person have the disease, right? Based on the formula for conditional probability, right? You're taking this, multiply this, right? Multiply this based on the formula, you are getting probability of disease intersect with positive result, right? So this is why I multiply, right? So I add up these two because there's two possibility. Either they have disease positive or don't have the disease but they still get positive. So okay, let's calculate what is the probability that the test will give positive for a member that tests. All right, which we're giving 0.0382, right? 0.0382, if you convert to percentage, is around 3.82%, right? 3.82% you will test positive. So okay, I try to explain more for you, okay? This one is to tell what any person that go to take the test, take this test, all right? A diagnosis test which is not named yet, all right? Maybe it's a COVID test, don't know, all right? We go to test. The probability that you get positive is overall is 3.82%, right? 3.82% means maybe you have the disease, you positive, or you don't have the disease, you still get positive, but it's 3.82% overall, all right? This is how people doing inspection or probability, right? All right, now look at the question B. Given that a positive response is obtained, given that, so means from here, what actually they want is, given that a positive response is obtained, calculate the probability that the person has the disease. Okay, read carefully. Given that a positive response is obtained, you know that it's a conditional probability. Given that a positive response is obtained, what is the probability that the person has the disease? This is for further investigation, right? To see is it reliability or not, reliable or not. So means that the person have the disease and positive, and divide by the probability of positive, right? So means the proportion, you see that disease and positive, so it's this one, right? 0.03 times 0.95 divided by this, right? 0.0382. If you are mathematically intelligent, you can see that this is part of this, right? Two of these total to be getting this percentage, right? So this is part of this, right? It's a proportion, right? So let's see how many percentage that you get. All right, which giving round off 0.7461, right? 4 decimal places, 461. Okay, for your knowledge, okay, this will be your answer because they asked to find the probability. They're asking to find the probability. So if they're asking to find the percentage, is around 74.61%. 74.61%, right? Means that out of all the positive tests, 74.61% of them have the disease. Alright, the meaning here is out of the positive result, those who test positive, 74.61 of them have the disease, right? So means that this should be improved. This should be improved. If let's say this is 90, it's even better, right? 99, even better. Means the test is more reliable, right? So never mind, you just need to know how to calculate, alright? You must understand, we're using the formula, right? D intersect with positive divided by the probability of positive, right? Probability of positive we can get from here, right? 0.0382. Disease and positive, we can just multiply with these two, right? Or we just take from here. So then we divide, we're getting the conditional probability for this. Alright, that's all for this video.